All right, ladies and gentlemen, good afternoon. It is certainly nice to see you guys. To what we call hypothesis testing about a mean. Now, what parameter represents that mean? Do you guys know? It's mu. Do you guys remember that? Mu? And yes, I also have notes, hypothesis testing about a mean here, right in here. Look at that. Oops. Those aren't notes. Let's go to the notes. And yes, we're going to start with what's called a large sample. So I'm going to put that in the comment section. Anybody there at home, by the way? Put that in the comment section. This is the hypothesis testing about a mean. And what I want to also say, if you guys want to see me do these examples in the notes, right? They're right here. The video's right here. It's like video notes. So if you said, okay, what is this video here? Right? Well, that's the notes, ladies and gentlemen. That's video version of the notes. It's hypothesis testing about a mean for a large sample. So you get to see all these examples in the notes, okay? But what I'm going to do here is I'm going to give you new examples. I'm going to make that up, okay? And so you can compare and contrast if you want extra examples here. All right, so I'm thinking ahead. Now this is going to be for what we call a large sample. Now, a large sample, if you guys forgot, is anything bigger than what? 30. And so the process by the p-value method, we're going to use the p-value method. The process is exactly the same. However, you just use a different TI command. So let's give you some language with mean. Okay. So, for example, I can say this. The mean age of college students is, bless you, 22 years, okay? As claimed by who? Good old Snodgrass, okay? So I want you guys to compare and contrast this. And then again, they're going to say a sample of 50 college students reveal a mean of 23.6 years, okay, with a standard deviation of 1.2 years. Use the 5% level of significance to test this what? Claim. All right. Now let's go through this, ladies and gentlemen. Let's read this here, okay? What does it say here? The mean. Okay, what parameter is the mean? That's mu. You see how this is different? Just change the parameter. It's a mean. And what are they saying? The mean age, what's the deal? Is what? Is 22 years. And that's going to be as claimed by who? Snodgrass. So I'm going to write that down. Mu, what's the deal? Is 22. And that is the what? Claim. Do you guys know, where does that belong? Is that a null? Or is that an alternate hypothesis? That statement. Where do you put that statement? Do you guys know? Where does that statement have to go? Huh? Nope. If it has a condition of equality, it's a null hypothesis. Yes.
You're right. I blanked out for a second.
Yeah. Okay. What's the opposite of that?
Mu
Mu is not equal to 22. Okay. Now, what kind of tail test is that? This is what? Not equal is always a two-tail what? Test. Bless you. Is that true? You guys okay with that? Let's get down to sample information. What does it say? A sample of what? 50 college students reveal a mean of what? 23.6 and a standard deviation of what? 1.2 years. So make sure you guys write that down. Okay, here's your sample. What's the sample size? $50. What's your sample mean? 23.6. What's the sample standard deviation? 1.2. Do we get all that information from the sample? Mm-hmm. And then they say use what? What's your level of significance now? 5% level of what? Significance. Now, that is alpha. Level of significance. Now, what you need to do is this. I'm going to say to you guys, we need something known as mu naught, just like you had p naught. What do you guys think mu naught is? You guys want to tell me what mu naught might be? Mu naught, ladies and gentlemen, is the mean in the null hypothesis. Mu naught here is 22. No. You know why? Because this is not a percentage. Okay? It's not a proportion. Proportions are not the same as the mean. This is a different parameter value. So then mu naught equals what? 22. Now, you might say to me here, again, in the notes, we're going to use a TI. Okay? Because if you went back to the notes, you go, what is this? Hypothesis testing about a large sample. And I'll go through these different examples, yada, yada. You're going to use what's called the z-test. So in the TI, the command you use is known as what? The z what? Test. You're going to use that z-test, ladies and gentlemen. All right, so you say, okay, TI, let's see what you have. Let's see. You go to stat test. You guys know where the z-test is? It's the first one. Bless you. That's number 1, okay? It's on stats. Good. Go down to mu naught. Mu naught was 22. Now, what is sigma, ladies and gentlemen? That's your standard deviation. So put 1.2. Sigma is your standard deviation. What's the sample mean? 23.6. Is that true? What's your sample size? 50. What kind of test is this? Is this a two-tail test? Good. So we have to have that a not equal. So I want you guys to double check that everything that we put here is in the TI. This is why I put all the information. I highly recommend you write it down this way too. That way you remember what to do. Now hit calculate. Calculate. Now we're going to look at the p-value. Is that true? And what do you guys notice about this p-value? Oh my gosh. What does that mean if it's e to the negative 21? It's scientific notation, and you're moving that decimal 21 spaces to the left, and you are correct. It's essentially saying that this p-value is approximately what? 0.000 if we go to the what? Thousandths. And like before, you say, is my p-value smaller than the level of significance of alpha? The answer is what? 0 certainly is less than what? 5%. So the probability that the null hypothesis is valid, the chance, that's a p-value. The chance that the null hypothesis is valid, that's smaller than what? 5%. It's not likely to be what? Valid. This is not likely as a probability. Now, any probability less than 5%, remember, was not likely. What that means is the null is low. If the null is low, the null has to what? Go. If the null is low, it has to go. How low is low? Less than the level of significance alpha. Has to be smaller than that alpha value. And it is. So you go back to the null and you say, guess what, null? You got to go. And what did you guys do then? If the null has to go, you accept the alternate. Is that right? What just happened to your claim? Claim is gone. So what's the conclusion? Yep, the sample does not support the what? The claim. That's the conclusion they're looking for, ladies and gentlemen. And you're using that TI calculator. What do you guys think? Isn't the modern method pretty quick and simple? Is it quick and simple? Okay. Let's give you guys another example here. The mean what? Hours of sleep college students get is not 8 what? Hours. As claimed by who? Good old Snodgrass, okay? So again, it's a hypothesis test, but it's now about a mean again. So we got a mean parameter. So we need sample information. So now we say that a sample of 200 college students reveal a mean of 7.2 hours with a standard deviation of 1.8 hours of sleep. Use the 10% level of significance to test this what? Claim here. Okay, so we're going to write that all down. So as we read this, let's see. What parameter? Is this a proportion or is it a mean? How do you know it's a mean? Good. It says the mean hours of sleep is what now? Is not what? 8. And that's as claimed by good old Snodgrass again. So, what does not mean? What is that? That's short for is not equal. Is that true? Okay, so we're going to write this down again. Mu is not 8, and this is called the claim, okay? We need to know that. Always write that down. So mu is not 8. Now, what do you guys have to remember as well? When you set up the hypothesis, ladies and gentlemen, you have to remember, where does that belong? Is that a null or is that an alternate? It's an alternate? So where does that go? On the bottom. Is that true? You say, how do I know it's an alternate? It does not have a condition of equality. Not equal is non-equality. But the logical opposite is mu equals 8, and that's a null hypothesis. So this is your setup. So far, so good? Okay, you guys okay with that? So far, so good? Okay. Let's read the sample information. What does it say? Sample of 200 college students reveal a mean of what? 7.2 hours with a standard deviation of 1.8 hours. So let's write this down. Sample information. What's the mean? Or I'm saying, what does it say? Sorry. N, X bar, and S. Is that true? What's your sample size? 200. What's the sample mean? Sample standard deviation. 1.8. Is that right? What do you guys always have to remember here? What's that 8 represent? That is what? Mu naught. Okay, so mu naught is 8. What kind of test is this? Anybody want to tell me? What, why is that two-tail? Because the alternate hypothesis has what? Not equal. When the alternate hypothesis has not equal, it's always a two-tail test. All right, good. Wow. Okay. So what do you guys use here in the TI? We use what? This is a z-test. Easy peasy lemon squeezy? Okay. All right, now get out the TI calculator and say what? Stat test. Isn't z-test number 1? Z-test is number 1. This is a z-test. Okay. What's your mu naught? 8. What's the sigma, which is really S? 1.8. Okay, good. What's the sample mean? 7.2. What's your sample size? 200. Is that a two-tailed test? So that's a not equal. Hit what? Calculate. Ladies and gentlemen, what is your p-value? What's the p-value? It's 3.284 times 10. That's e to the minus 10. That means move the decimal 10 spaces to the left, okay? What does that actually mean? It means your p-value is it's approximately what? 0. Is that p-value low? It is low. How do I know it's low? It has to be smaller than alpha. It sure is, because that 0 is less than, hey, what is alpha anyway? What do they tell us about alpha? What's alpha? Alpha is what? 10%. Is that smaller than 10%? It sure is. Is that right? 0 is smaller than 10%. So your p-value is low, and the null has to what? Go. When the p-value is low, the null has to go. Goodbye, null, but you're hugging the what? Alternate. What does the alternate happen to be? The alternate happens to be the claim. So this hypothesis test is revealing that the mean hours of sleep certainly is not 8. What does that mean about the claim? The sample what? What's your conclusion? You got to have that conclusion. Does your sample support the claim, or does the sample not support the claim? Are you hugging the claim? If you're hugging the claim, then what do we say? The sample what? So supports the claim, because you are hugging the claim. Okay, if you crossed out the claim, sample does not support the claim. If you hug the claim, sample supports the claim. You're hugging the claim, okay? Notice up here, you crossed out the claim. Sample does not support the claim. Here, hugging the claim, the sample supports the claim. What do you guys think? Is that okay? All right, let's have you guys try one out. How's this? I'm going to say the mean, what? What do you guys have? The mean what? Number of friends on social media college students have is more than 50, as claimed by who? Snodgrass. A sample of what? 100 college students reveal a mean of 50, let's say this, 62.8 with a standard deviation of 15.6. Use the 5% level of what significance to test this claim? So we're going to have you guys try this example, okay? And then let's see what you guys get. We're going to give you guys some time here. Try that one out. All right, you guys ready for this? What does it say? A mean of what? What's the story here? They're saying college students have a mean that's more than 50. And these are friends on social media, right? As claimed by Snodgrass. You guys have social media? Maybe. So mean mu, and how do you describe more than? Isn't that strictly greater than? The more than, greater than? And this is the claim. So mu greater than 50. Here's your what? There's the claim. So where does that go, ladies and gentlemen? Is that a null or is that an alternate? Where does that go? Null or alternate? Null or alternate? Where do you guys place it? Is there a condition of equality for more than or greater than? Is there any equality there? No, so it's an alternate what? Hypothesis. Good. All right. The logical opposite is less than or what? Equal. What kind of test is this? This is a right tail. How do we know this is a right tail? The alternate hypothesis always tells us what kind of test this is. So if it's pointing to the right, ladies and gentlemen, it's a what? A right tail. Okay, you guys okay with that? All right, now let's read and get our sample information. So we're going to write down the sample information. And as we read, what does it say? A sample of what? 100 college students reveal a mean of what? 62.8 years. I'm sorry, friends. Standard deviation of what? 15.6. So a sample of what? 100. That's my sample size. This is the mean. And then we have a standard deviation. So sample size here is going to be what? 100. Sample mean. What's the average number of friends? 62.8 with the standard deviation being 15.6, ladies and gentlemen. So double check your sample information is correct there. Okay, because we're going to use what level of significance here? 5%. Is your alpha. So you guys have all the information now that you need to use. What's the command? What's it called? The z-test, okay? You're using your z-test. Anybody have any questions on all that? You guys see, isn't that all the information that's there? All right, let's get out the z-test, ladies and gentlemen. Here we go. Stat test. Z-test is number 1, isn't it? Is it number 1? Okay, so it's already on that. Now, let's fill this out. Oh, we forgot. Who can tell me? I forgot something. What did I forget? What's the 50 represent? That's the mean in the null what? Hypothesis. That's the first entry in z-test. They want to know what that is. So mu naught is 50. Oh, okay. We left it out. Good. Okay. All right. So let's punch this in. Okay. So mu naught is what again? Good. You see how we need it? What's your standard deviation? Is that 15.6? What's your sample mean? 62.8. And again, what kind of sample size? I'm sorry. 100 now. What kind of test is this? Is this a two-tail test, a left-tail test, or a right-tail test? It's right tail, so what do? I gotta go all the way to the end there, okay? Make sure that inequality is pointing to the right because this is a right tail what? Test. You can even double check everything in your notes. Right tail test. You guys see what I'm saying? Now, what do you guys hit? Hit calculate. What's that p-value? Oh my gosh, is that low? Yeah. What is it approximately going to be again? Isn't that e to the minus 16? That's 10 to the minus 16. You got to move the decimal 16 spaces to the left. So, ladies and gentlemen, that p-value is certainly low. You say, how low is the p-value? It's almost zero. It's close to zero. That means the null hypothesis is not likely. So the p-value is low. The null has to what? Go. Remember, when that p-value is less than alpha, 0 is smaller than the 5%. That is true. That means your p-value is low. The null has to what? Go. So go to the null and say goodbye, null. You're gone. If the null is gone, what's the story with the alternate? You're hugging that alternate. And the alternate happens to be the what? The claim. Are you guys hugging the claim? So what does that mean? The sample what? Supports the what? Claim. All right. So we have this thing called the what? The z-test. It's a hypothesis test for a mean of a large sample. Now, what I'm going to do here now is this, ladies and gentlemen. We're going to give you guys a break. You guys feel like a break? Sure. No? You guys want a break? Bread? We'll give you guys a quick break, okay? And we're going to look at hypothesis testing about a mean. But this time, we're going to do this for a what? For a small sample. So we're going to do everything that we already did today, but can you guys tell me? First of all, what's a small sample? Sample size that's small. What is that? Do you guys know? Anything that's under what? 30, yes. And so this is hypothesis testing about a mean. The parameter here is what? Mu. Okay? And you guys know what you're going to use in the TI? This is what you guys use in the TI. You've been using z-test. Is that true? Z-test is for a large sample. You're going to use what we call a what? T-test. And a t-test is used for a small sample. Small sample, anything under 30. Now remember what the t-distribution is. The t-distribution, by the way, we said why a t-test? Well, a t-distribution is similar to the z-distribution. T approximates z for a what? Small sample. So this is why they call it the what? The t-test. So everything that we've done, we could do again, but this time we'll take a small sample. So this is the only difference is in the TI, it's t-test. So that's what I wanted to go over today, ladies and gentlemen. Okay, so let's give you guys another example here so you can see the t-test. It's very similar. Oh, let's say this, the mean what? The mean lunch bill. Do you guys have a nice lunch? What'd you have for lunch? My other class said they like the Husky store. They eat there at the Husky. They eat some of the burgers there. But they said it was expensive. Is it expensive there?
I wouldn't know. I don't go.
I don't know either. I haven't been there in quite some time. So the mean lunch bill for college students, we're going to say is what? $15. As claimed by good old what? Snodgrass. Okay, a sample of 20 lunch bills reveal a mean of $14.25 with a standard deviation of $2.20. Use the 5% level of significance to test what? This claim. Okay, so let's try this out. Let's read this here, okay? It says a mean lunch bill is supposed to be what? $15 as claimed by good old Snodgrass. Is that true? So what parameter is mean? Mu. What about the word is?
Equal.
Good job. So this is just saying that mu equals 15, and then here is your what? Claim. So, ladies and gentlemen, H naught, H1, let's ask you, where does this hypothesis, where does that claim go? Is that a null or an alternate?
Unknown.
Null or alternate?
Unknown.
It's a null. How do you know it's a null?
Because it says equal.
Because of the condition of equality. Good job. Good job. Let's see if this audio is up. Yeah, the audio is up. Okay, what's the opposite of equal?
Not equal.
Not equal. Good. Okay. And moreover, what do we know? This is going to be what again? A two what? Tail test. Why is that a two-tail test? Because of the word what again? Because of that non-equal. The alternate hypothesis, ladies and gentlemen, there it is. Okay. So let's read further. We say, what does that mean? We say this, a sample of what? 20 lunch bills reveal a mean of $14.25 with a standard deviation of $2.20. So, sample size n, sample mean, sample standard deviation. Let's look at the sample. What's your sample size? 20. What's the sample mean?
14.75.
$14.25. What's your sample standard deviation? $2.20. Is that true? So you could just read this, and then it says use what? The 5% level of significance. What's this? Alpha is what? 0.05. 5%. Now, do not forget, ladies and gentlemen, what don't you guys forget here? What does that 15 represent? What is this? What is that called? So mu naught equals what? 15? Okay. This is what? In the TI, what do you guys use? What did we say we use? T what? Test. So because the sample size is small, what is small? Anything under, no more than 30. Small sample. You guys use a t-test in your TI calculator. All right, here we go. Stat, test. Where is t-test? It's actually number 2. Is that right? So what is mu naught? 15. What's the sample mean? 14.25. What's the sample standard deviation? 2.2. What's your sample size? 20. Is that right? What kind of test is this? It's a two-tailed test. Hit what? What do we hit on this one? Calculate. T-test, ladies and gentlemen. Let's take a look. What's this p-value? Can you guys read the p-value here? What's that p-value to the nearest thousandths? 0.144. Good job. It's that p-value, 0.144. Now we got to look at this and say, is that p-value, is p less than alpha? P, what else? Alpha. What are we saying? .144 is less than 0.05. Is that true? Is 14.4%, because remember, that's a percentage written as a decimal. Is that percentage smaller than 5%? Say what? No, it's not smaller. So the p-value is not low. What does that actually mean if this is not the case? You guys remember? Then you have to keep the what? You keep the null. Good. If it's less than, we say the null has to go. But if it's not, it doesn't go. We keep the null. It's not smaller than the level of significance. So keeping the null, we hug this null, ladies and gentlemen. If you want to see it specifically, keeping the null really means getting rid of the what? Alternate. And when you keep that null, what are you doing? What does that mean? You're hugging the what? You're hugging the claim here, okay? You're hugging the claim. Now, ladies and gentlemen, we're hugging the claim, so what does that mean? The sample is saying what? The sample supports the claim. It's a small sample, it's a t-test, but this is supporting what? Supports the claim. The sample supports the claim. The claim is that the mu is 15. And there it is, ladies and gentlemen. This is a t-test. Anyway. What's that? Mm-hmm. Yeah, time flies when you're having what? Fun. This is so fun. This is all you got to do. Remember, for a small sample, anything less than what? No more than 30. You're going to use the what test? T-test. If it's bigger than 30, you use the what? Easy peasy, lemon squeezy. Do I give you guys notes on your exams that you guys have there in that summary sheet? Yes. Is it there? Yes. Anyway, let's try another. You guys want to try one? Sure. Okay, let's say the mean what? Oh, the mean what? You know, we always have to try to keep it interesting for college students, right? The mean, let's say the mean IQ scores for college professors is more than, let's say, 125 as what? Claimed by good old who? Snodgrass. I'll just call him Mr. Snod. How's that? A sample of 25 professors' IQ scores. Professor IQ scores. Are they vacuuming? I know there's a leak. Reveal a mean of, let's say, 122.8 with a standard deviation of, let's say, 10.2. Use the 10% level of significance to test this claim. We'll give you guys some time here to try this out. Use the t-test. It's a small sample. All right, ladies and gentlemen, do you want to try this out? You guys see what I'm saying? Let's take a look here. Let's read it. It says the mean IQ scores for college professors is what? More than 125. Who knows? I doubt it. As claimed by good old Snodgrass. Okay, so the parameter for mean is mu. And more than, what inequality do we associate with more than? Do you guys know? More than is what? Greater than. So you have what? Mu greater than 125. And what is that going to be? That's your what? That's your claim. H naught. H1. So where does this actually go? Is that a null or an alternate? Is that a null or an alternate? Where does that go? Why is it an alternate? No condition of equality. That's correct. What's the logical opposite? Mu is greater than, it'll be less than or equal to 125. All right. Everybody okay with this so far? So far, so good. Now remember that when I write this down, what I notice right away is that this is going to be what kind of test? A right tail. How do we know this is a right tail test? Isn't that inequality pointing to the what? That's pointing to the right. If it's not equal, it's two tail. If it points to the right, it's a right tail. If it points to the left, it's a what? Left tail. Is that true? All right, ladies and gentlemen, let's read. Let's get the sample information. What does it say? A sample of what? 25 professors' IQs have a mean of 122.8 with a standard deviation of 10.2. So here's the deal. N, X bar, and S. So your sample information here The sample size is what again? 25. What's the sample mean IQ? 122.8. Sample standard deviation of the IQ is 10.2. Now, don't forget, the mean in the null hypothesis, this is mu is less than or equal to 125. So that means mu naught is 125. Okay, you guys okay with that? Now, here's the deal. Why do we use the t-test? Because your sample size is what? Is small. T-test. Okay. What's the level of significance again? Oh, alpha's what? 10%. There we go. Stat test. Go down what? T-test. Okay, what's your mu naught? Mu naught is what? Is 125. What's the sample mean? 122.8. You guys okay with that? What's the sample standard deviation? 10.2. What's the sample size? It's 25. Isn't that small? What kind of test is this again? Anybody want to tell me? This is a what? Right tail test. Okay, it's a right tail. So make sure you have your inequality pointing to the what? The right. And then hit what? Calculate. Ladies and gentlemen, what's that p-value? To the nearest thousandths. 0.854? Wow, p-value is 0.854. That's kind of big, right? So your p-value is kind of big. Isn't that p-value bigger than alpha? So p is bigger than alpha. What we mean is, well, yeah, sorry. We need the p-value to be what? Less than alpha. So we're going to say this is not less than what? Alpha. What does that mean if the p-value was large? Do you guys know? What did that mean? If the null is low, the null has to go. But if if the p-value is low, the null has to go. Here, the p-value is not what? Low. So what does that mean about the null? We have to do what? You guys keep the null. So keeping the null, here, you keep that null, and you get rid of the alternate. But by getting rid of the alternate, what did you also get rid of? You got rid of the claim, didn't you? So what do we say? The sample what? Does not support the what? The claim. The sample does not support the what? The claim. So hopefully you guys had that kind of situation. Okay? Did you guys get this information here for you guys? Did you guys use the t-test? All right, good. Now I'm going to give you my favorite example that I want you guys to pay close attention to. Okay? Close attention to. Here's what's going to happen. The mean number of pets college students have is more than 2, as claimed by Snodgrass. A sample, let's do this. I'm going to ask you guys here, I'm going to ask you guys, how many pets do you have? How many pets do you have?
12.
12. How many pets do you have?
Oh, honestly, don't remember.
What do you think?
I don't know. Let's go
20
20.
pets? Okay. How many pets do you have?
I have 2.
How many pets do you have?
3.
How many pets do you have?
4.
How many pets?
0.
Finally, a man who makes some sense. How many pets do you have? How many pets do you have?
2.
No, let's stop right there. Use the 5% level of what? Significance to what? Test this claim here. So I want to share with you guys this. This is an extremely important example that I'm going to say really pay attention to this. It's really nice. So what's the claim, right? The mean number of pets is what? Is more than 2, as claimed by good old Snodgrass. So there's Snodgrass again. How do you represent more than? Greater than. Mu is greater than 2, and then that is the what? The claim. So, where does that go? Is that a null? Or is that an alternate? You guys want to tell me? Where does that go? Is that a null or is that an alternate? Oh, it's an alternate. Why? There's no condition of equality. You don't see equal there. So, good. Now, the opposite of that of greater than is less than or equal to 2. So, again, this is going to be a what? A right tail test. Okay, you guys okay with that? You guys see the point? Now, what's the difference here? Let's share with you guys. You guys see that they took a sample now, didn't they? So you might say, Mr. Judge, how do I get my sample information? Well, do you guys remember? These are the data values. These are the X values, okay? So how do I get the sample? I need 3 things. I need the sample size, I need the sample mean, and I need the sample standard deviation. How do we get those things? Do you guys remember? You're going to use the TI. So go back. You guys even had this on a test. I'm going to say, do you guys remember? Go to stat what? Stat, edit, edit. Do you guys remember how to use this? Yes. So go up there and hit clear. Clear out the data. That's from my last class. Now enter all your data values that you collected. 12, 22, 3, 4, 0, 2, 2. Enter that. So I'm gonna scroll out. I'm gonna try to enter this so you guys can see it. 12. Enter. 20, enter. 2, enter. 3, enter. 4, what? Enter. 0, enter. 2, enter. 2, enter. And then what happens after you enter? You go to stat and what? Calculate one variable stats. This is list 1. Okay? So double check. Can you guys see any important information that you need? What are they saying here? Can you guys tell me what the sample mean is? You guys remember that? One variable stats. What's your sample mean? Isn't it 5.625? Isn't that the first one? Okay, what's the sample standard deviation? Do you guys remember this? It's the SX. It's 6.844. Okay, you guys okay with that? SX. How many data values were here? 8. It says N is 8. Do you guys see this here? So I want to say to you guys, if they give you a list of data, and they will, you have a way to get all the information that you need still. This is, again, this is a small sample. Isn't that 8 small sample size? Sure is. Okay, you guys see, this is more realistic. This is realistic because they give you data values now. But it's small. That's good. Don't forget, you always need mu what? Naught. So you go to the mean and the null hypothesis. What's mu naught going to be? Mu naught is what? 2. This is called a what? T-test. T-test. The level of significance, don't forget, they want to see 5% level of significance, okay? So we're going to test this hypothesis with alpha being 5%. We got to do the modern method today. Here we go. Stat what? Test. Where is t-test? Number 2. Why do I use a t-test? Anybody want to tell me why? Small sample, 8 data values. Okay. So what is mu naught? 2. And if you're awake, what do you guys notice? The calculator has built-in memory. Doesn't it have the sample mean, sample standard deviation, sample size there? It kept it in the memory. Yes, that's really nice. I love that. Is this a right tail test? It is. You guys see what I'm saying? All that's in your calculator. Good. It's a right tail test still. So just scroll down to what? To calculate. And, oh, we got to check the p-value. What's this p-value? Let's go to the thousands. P is approximately 0.0 what? 89, is that true? And what is 0.089? Is that p-value less than alpha? Let's see. 0.089, is that smaller than 5%? You guys have to know this. Is 8.9% smaller than 5%? Say what? No. So in other words, the p-value is not smaller than the level of significance. What does that mean? You keep the what? The null. 8.9% is not smaller than 5. So we're keeping the null. And you might say, hey, Mr. Judge, this is a bit odd. And I'll tell you, yeah, you're keeping the null. And you're getting rid of the what? The alternate. Sample does not support the claim. Sample does not support the claim. However, note something. What if they said to you, hey, I don't want you using the 5%. I want you using 10%. What if that was a 10% level significance? And you go, oh, if alpha's 10% now, let's see if they did that. What do you guys notice? If they gave the 10% level significance now is 8.9% right here, the p-value, smaller than the level significance now, you say what? Yes. Isn't 8.9% smaller than 10%? That means the p-value is low. The null what? Has to go if that p-value is smaller than 10%. So that's enough, ladies and gentlemen, to change your what? Conclusion. The null has to go, and you're accepting again the what? The alternate. And in this case, the sample will what? Support the what? Claim that students have more than what? 2 what? Pets. Now, you might say, but the prior example with 5% had a different conclusion. Yes, it did. One of the issues is this. You had a very sensitive test at 5%. It could be more sensitive at 1%. So the big problem, though, is your sample size is so small. It's only 8 data values. So when you have a super small sample and then the test is sensitive, you know, it's kind of a small issue. But nevertheless, if you have that situation, what do you guys use for hypothesis testing about a mean and a small sample? What do you guys use? The T what? You use the TI, but what's the command? T-test. Good job. We'll see you guys when? On Thursday.